Hi everyone. So till now we have covered 98 marks of syllabus of IBBI exam, and today we are going to start our last playlist, which is on statistics. As per revised syllabus with effect from July 2022, it carries 2 marks. These 2 marks appear to be very small. However, sometimes these 2 marks turn to be very crucial because many times aspirants get only 59 marks or 59.75 marks. So these 2 marks are very easy to score. This is simple 5th, 6th or up to 10th class maths, which all being we are engineers, so we all have read all these simple statistics formulas, and we can easily score 2 marks. Though this topic is little bit lengthy, but very easy to understand, and you can score 100% these 2 marks after going through this playlist. We'll try to cover this playlist into 5 sessions. Today is going to be first session. So in today's session, we're going to discuss about types, collection, use, processing of data. Then we'll also talk about graphical presentation of quantitative data, histogram, frequency polygon, frequency curve, Ogives, etc. And then we'll also discuss about graphical presentation of qualitative data. So quantitative data and qualitative data. This is the full IBBI syllabus, which carry 2 marks, and we'll stick to this syllabus specifically. So first part of this session is data classification and processing. So what is data? Data is nothing but a collection of observation. It is also called a data set, or we can also call it simply as data. And a single observation in this data is called data point. Please remember, this data could be of 2 types: quantitative data and qualitative data. So quantitative data is related to occurrence or non-occurrence of some phenomenon, and quantitative data, it is the information dealing with magnitude or amount of value of entities determining a phenomenon, like temperature. Like rolling a, this example of this quantitative data is rolling a dice. We'll get 1, 2, 3, 4, 5, 6. Or tossing a coin, we'll get head or tail. This is example of quantitative data. And qualitative data is temperature. It ranges from somewhere maybe -30, 40 to +40, 45, sometimes 50. In India, it ranges from 0 to normally 0 to 30, 40, 50. So collection of data. One should select the observations, which is also called data points, which represent all relevant groups. The data can be collected through any of the 2 sources, primary data and secondary data. So primary data is the data collected for the first time by the researcher or investigator through some field survey, like exit poll data. That is the primary data. Secondary data, which has already been collected by some other agency or researcher. You can collect this data from published sources like departmental reports or census, etc. So if we do some research through Google with and take out some data which is already available on Google and do some interpretation basis on that data or compile the data, that is called secondary data. Use of data. Past data is being used to predict the future trends. So we'll stick to the specific topics and areas which are important from exam perspective. Otherwise, this quantitative statistic topic is very large and cannot be covered in 4-5 sessions. So if examiner asks about any question about use of data, then 1 mark theory question may come. Past data is being used to predict the future trend. Please remember from exam perspective. sample and population. Population is a whole data, entire set of data. Sample is a fraction of whole data. And representative sample is a type of sample which contains the relevant characteristics of the population in the same proportion as they are included in that population. So if we take out a sample, and which is say for example in India, there is a sex ratio of say 50-50, 50% male, 50% female, for example. Out of 130 crore population, 65 crore is male, 65 crore is female. So if you take out a sample from Indian population of say 1 lakh people, we talk to 1 lakh people, and if those 1 lakh people are also having same sex ratio 50-50, then it is called a representative sample. If the sample which we take out from population, say 1 lakh people, represents male female sex ratio of 50 to 48 as against 50-50 sex ratio of the entire population, then it will not be a representative sample. Please remember. Next is processing of data. So once we get the data, we need to process it. So raw data or ungrouped data is the original data after collection. It could be primary or secondary, but before processing by any of the statistical method, that is, it is the arranged or analyzed. So before arranging or analyzing the data which we gather from primary or secondary source is called raw or ungrouped data. Further use of biased and incomplete data can also lead to poor decisions. Please remember, once data is arranged in ascending or descending order, it is called data array. This is also important terminology from exam perspective. What is data array? The data array is nothing but arranging data in ascending or descending order is called data array. And there are many ways to sort data basically. So if data is quantitative, the data points can be sorted from lowest to highest. If it is quantitative, right, then we can sort data from lowest to highest in numerical value. However, if data is qualitative, then data must be organized or divided basis some principal and number of data points falling in each category must be counted. So this is also known as frequency distribution. The frequency distribution is a table that organizes data into known overlapping classes, that is into groups of values describing one characteristic of the data. If there exist n observations in the data, then ideal number of classes is equal to 1 plus 3.3 log 10 base 10 n. Please remember this formula. Numerical doesn't come out of this formula, but 1 mark theory question may come from this formula also. Very rare chances that you will get numerical on this ideal number of classes, but still you remember the formula. Ideal class width. The formula for calculating ideal class width is largest value in data minus smallest value in data divided by total number of classes interval. Let us understand with the help of an example. So let us prepare frequency distribution of data having 30 observations. So this is the set of observation, right? So this is the raw data. We have not organized it. So data given total number of observation n is equal to 30. Highest value data is 17. This can be seen from here. And lowest value of data in 15.20. You can see from this entire data, the lowest data point in this entire population or sample is 15.2. However, the highest point is 17. So as we know that ideal number of classes is 1 plus 3.3 log base 10 is to power n. So it is 1 plus 3.3 log 10 n 30. So it is 5.87. Say 6. Right? And ideal class width formula is there. Largest value in data minus smallest value in data. 17 minus 15.2 divided by total number of classes interval. So here this is equal to 6. So you have to make it to the nearest place. Please do remember, it cannot be in fraction. Number of class widths, number of class interval cannot be in fraction. So you have to make it to nearest place. 6 is the answer. So 1.8 divided by 6 is equal to 0.3 is the ideal class width. The frequency distributions are prepared using 6 classes of each width with 0.30 is called continuous frequency distribution. This is the example. So this is the continuous frequency distribution. Lowest width is 15.20 to 15.50, then 15.50 to 15.80, 15.80 to 16.1. So these 6 classes are there. Then the data which is given in the previous slide, we have to take out how many number given in the data falls in this class width. So 2 items are falling in this. So likewise 30. Total 30 entries were there. So if we see, 2 were falling in first class, 5 were falling in second class, 11 were falling in third class, this class interval. 6 items are following in this interval, 3 items and in this interval respectively. So this is the frequency. If we divide this 2 divided by 30, that gives us the relative frequency. So that is, this is the relative frequency formula, f divided by n. This is f and this is n, 30. So always remember, total relative frequency of entire set of data is always 1. This is also need to be remembered. Discrete frequency distribution. In case we consider frequency for each distinct data starting from lowest to largest, the type of frequency distribution is called discrete frequency distribution. Earlier we discussed about continuous frequency distribution. Now we are explaining discrete frequency distribution. In case of qualitative data, if we consider classes responding to each category in the data set, we get a discrete frequency distribution. So let us understand this concept of discrete frequency distribution with the help of another example. For example, guests staying in a hotel Marada Inn were asked to rate the quality of their accommodation. So these are the 5 class of quality rating: excellent, above average, average, below average, and poor. E, A, B, A, P. So now we have to prepare a discrete frequency distribution of rating provided by a sample guest of say 20 guests. The hotel management took rating from 20 guests and this is the rating. BA means below average. First guest gave rating of BA, below average. Then A, that means average rating was given by second customer. AA, above average rating was given by third, fourth, fifth. These 5 customers, second to 7 customer, gave rating of above average. Then these next two customers gave rating of B, below average. Then average, PP, poor, double A, AA, above average, like this. 20 customers gave this rating. Now first we have to as these 5 rating classes are already given and this data is also given. So out of 20 we will see how many customers gave rating of poor. So 2 customers gave rating of poor, that is why frequency for poor is 2. Likewise below average was 3, average was 5, above average was 9, and excellent, 1 customer gave excellent rating. So total 20 customers were there and this is the relative frequency f divided by n. N is 20. So 20 divided by 2 divided by 10, it is 0.10. It is relative frequency of the customer who gave poor rating. Likewise, since 3 customers gave below average rating, so relative frequency of these customers was 3 divided by 20, that is nothing but 0.15. And if we convert it into frequency, percentage frequency, and then multiply these numbers with 100%, so that will give 10%, 15%, 25%, 45%, then 5%. So this is the solution. Graphical diagrammatic presentation of data. Frequency distribution gives tabular presentation of the raw data. Such a grouped or tabular data can be nicely presented as diagram or graphs for better understanding. So till now we have understood the tabular data. Now we will discuss this data with the help of graphical presentation. Obviously, pictorial view of data gives us a better understanding. It is always understandable. Now quantitative data can be represented by histograms, frequency polygon, frequency curve, Ogive curve, etc. While quantitative data can be represented by bar charts and pie charts. We understand all these tools of graphical presentation step by step in coming slides. So first is histogram. quantitative data. So in histogram, the variable of interest is placed on horizontal and frequency is placed on vertical axis. I do remember this line. A rectangle is drawn above each interval with its height equal to the interval's frequency or relative frequency or percentage, whatever may be the case. You may consider the interval frequency. We'll see a diagram in next slide. A histogram has no separation between rectangles of adjacent classes. Please remember this point. In histogram, the vertical bars do not have any separation among with the adjacent class rectangle. Frequency polygon. If midpoints of the upper side of the rectangle is a histogram in a histogram are connected by a straight line, the resulting curve is called frequency. So whatever vertical bars are there, this like this one bar. So we'll take out the central points and we connect it with central points, through by straight lines, resulting in a curve is called the curve so come out is called frequency curve, frequency polygon. And third one is frequency curve. If points on frequency polygon are connected by a smooth curve, then it is called frequency curve. So this is the with this graphical picture you can see. So so this is the graphical picture. First class was 15.20. If you remember in previous slide, this was the first class 15.20 to 15.50. So this is the, and two items were there for this thing. So this is the point, middle point, right? So if you so for these vertical bars, these vertical bars uh, adjacent to each other are called histogram. So these vertical bars are histogram. If we connect these middle points of these 1 2 3 4 5 6 these bars with straight line, then it will give us a frequency polygon. So this is a straight line, this straight line 1 then 2 then 3 then 4 then 5 then 6 and then 7. So if we connect these 7 lines, these combination, this 7 line is frequency polygon. Please remember, sometimes the examiner may show you this graph and may ask a question, which one is graphical curve, which one is graphical polygon, which one is histogram. So very easy question to score in exam. And if you connect these points with the help of a smooth curve like this one, remember, goes up, down, straight, then up. So if you connect these 7 points with the help of these 8 points with the help of a smooth curve instead of straight line, it is called frequency curve. Ogive. Ogive is a cumulative frequency distribution that enables to see how many observations lie above or below certain values, rather than merely recording the number of items within interval. Ogive can be of two types as under less than ogive and more than ogive. So less than ogive is the cumulative distribution, less than as under. So for example, less than 15.20, if we are discussing all these curves with the help of same data set. So there was no number which was level less than 15.20. So cumulative frequency was 0. Then less than 15.50, there were two entries, if you remember. Then 15 point less than 15.80, two entries were this up to this point, and between interval of 15.50 and 15.80, there were additional 5 entries. So total 7 entries were there, less than 15.80. Then up to 16.10, 18 entries were there. Up to 16.40, 24 entries were there. Then up to 16.70, 27 entries were there, and less than 17, 30 entries were there. Likewise, more than ogive is also there. So more than ogive is cumulative distribution, more than this sign, more than, greater than. So here in this case, more than 15.50, but total all data points were more than 15.50 value. And then more than 15.50, there were 28 data, because two data points were lying between this interval 15.20 to 15.50. So remaining 28 were more than 15.50. Likewise, more than 15.80, 23, 16.10, 12, 16.406, 16.703, and more than 17 was 0 because all data points were less than or up to 17. So this is the graphical presentation of more than and less than ogive. Sometimes this question is also asked in exam by asking, examiner may show you the pictures and ask which one is less than ogive, which one is more than ogive. So this is the less than ogive graphical presentation. So 15.20, 15.50. So this is the less than ogive, and this is the more than ogive. Please remember, less than ogive is always upward slope, and more than ogive is downward slope. So this is a graphical presentation of pie chart. If you remember the hotel example, a pie chart is a circular depiction of data where area of whole pie represent 100% of the data, and the slice of each pie represent a percentage breakdown of the different class and category. So if you remember example of that hotel wherein 20 customers were asked to give rating of the hotel services. So out of 20, one customer gave excellent, if you remember, right? And two customers had given poor. So 10% cumulative frequency customers gave poor rating. So this is a graphical presentation of excellent 5%, poor 10%, below average 15%, average 25% and above average 45%. So this is the bar chart presentation. Please remember, difference between histogram and bar chart is that in case of histogram, these vertical bars are adjacent. There is no gap between these two vertical bars, right? Rectangular bars. Or in case of bar chart, there is a gap between these two vertical. This is a little bit confusing. Please remember difference between histogram and bar chart. Examiner may give you pictorial view and ask you whether it is bar chart or histogram. So it is similar to histogram except that in case of bar chart, in this case the bars are separated from each other. So thank you very much for watching first session of current playlist. So before I'm going to tell you what we are going to have in next session, I would again request you to please subscribe to the channel and click on bell icon. Also do like to the session video so that new videos will come as soon as possible. So this is what we are going to discuss in upcoming session. Probably in 4 sessions we will try to cover this entire syllabus. Next session we are going to talk about central tendency, dispersion and skewness. Then we'll also talk about third session we are going to discuss about probability, sampling and sampling distribution. Then fourth session we are going to discuss about regression, correlation, multiple correlation, and the last session we will going to discuss about time series and index numbers. Thank you.